concepts are clear. Anything we do, it's clearly stated in these, I mean, you can see it easily without spending a lot of time worrying about some of the finer points. So let me go ahead and first start with any questions you have about any of the homework. Now, I'm under the assumption everybody did the homework from now on. If you haven't done it, you need to make absolutely certain to start keeping up, because it's going to get more and more complicated very quickly. And we're doing right now, we're talking about mean, talking about the mean squared value, the standard deviation, and a couple things I didn't talk about is the median value. I did talk about the median, the average value, or really average if it's discrete, and then the median value. We're going to talk about the mode today too. Now this is in the book. So I'm going to, first, any questions about any of the homework, anything like that? All right, it's important to keep up with this.
Hold on. I think I have a question.
What?
I said I think I have a question.
Okay, go ahead.
Sorry.
Listen, tell you what, while he's finding that question, I want to cover one last thing. It's called mode. How many remember or look at what mode is? Anybody? In your own words, what is it?
The number that I guess occurs the most in a set? Or
The most, if it was a continuous random variable in the PDF, it would be the largest value of the PDF function. All right, let me just show you this. But your point is, you're right about this. So we talked about, well, let me just get to it. Mode is something you don't normally hear talked about. What it means basically, if you have a probability density function of x, it's usually shown as like f sub x of x. It's a small letter, and the sub x means it's a density function related to the variable x. And it's going to have something like this. If this is x, it'll have something, and the mode is the maximum value. That's all it is. So if you think about that, it's where it's most likely, you might say, over a small range of values to occur there. So how do you always find a mode if you have a probability density function? Well, what do you always do if you want to find the maximum of any continuous function? Class? Maximum value. Just tell me. Anyway. If I gave you the function, let me go ahead and give it to you. Suppose I gave you 1 over 1 minus x, all right? And this is for x greater than 2 less than 3. How do you find the maximum value? How about this? Let me do it this way. Let me make it x minus 1. It'll be clear. Anyone at all? What do you always think of?
Just plug in the largest value.
How would you find the largest value? That's what I'm getting at. Just tell me. Take a derivative and set it equal to 0, right? That's where the slope of the line is 0. Remember, at the crest here, if you look at the slope, it's 0, isn't it? So you take a derivative of this, and I'll just get this. So you take a derivative of f of x with respect to x and set it equal to 0, right? And then if there are multiple zeros, you have to test each one of those. That gives you the value of x. Then you have to take that value of x and plug it in. One second. I don't know if that's mine, but it sure sounds like it. I get these numbers. I think there might be some bad weather later today. I don't know if it's going to happen or not. Did you look at the weather?
Yes, for the next like 10 days it's supposed to be raining.
Well, I didn't bring an umbrella, but I figured out how to get out. Anyway, set it equal to 0. Whatever values sustain that, you have to go back into the original function and evaluate it to see which is the largest. Y'all with me? So that's the mode if it's a continuous. if it's a PD, if you have something, now you're right about this. If you have something where you have a discrete, this is probability mass function, and say it's P of X, right here, you find the maximum value. The maximum value of this, whatever value of X does that is the mode. With me, everyone, on this? And the median value is what? For discrete numbers.
Center.
It's the one where if you take that number, the exact number of things are on one side or the other, less than or greater than. You with me? That's the idea of the median. And the mean value is
The average.
the average value. That's it, right? And the mean value of a continuous random variable or average value is just x times f of x dx integrated over the range of possible values. That's all it is. I wanted to make sure I said that and get it out so it's clear. Make sure you keep up. It's going to get very confusing if you don't. The next thing I wanted to do is go through some problems. In problem 1.76, I actually used ChatGPT to get all the wording, and I put it up there at the bottom of the last homework, I think. Did anybody see that? I just put it up there because I didn't want to type out all the words. And that actually does a pretty good job of showing you exactly what we're doing. And it was right. So I want to just tell you first, got to make sure it's right. Second, I did it. So I want to do a couple of these problems because they really showcase some of the basic concepts. I gave you these problems partially as a review. Some of this concept is earlier, right? And partially because the latter part, the mean, average, mean squared, and I think the third third central moment, I asked for things that I didn't cover in detail, but you have enough information to do them. So let me go through this one. These are good problems, by the way. Did y'all, if those that did them, how many realize these problems are like a little easier? Anybody realize that? I did this for a reason. I've taught out of that book, and I've taught out of a couple other books, random, and that book, really, the problems just bring out the points easy. You can see it. And I think it's beneficial. If you want me to, I'll just use the book Chan, bring out this stuff, but just waiting for someone else is a little tough. All right, so this is 1-7.6, isn't it? First one? So this is problem 1-7.6. Can you just, you got it there, I hope. If you don't have it, I'll leave it.
It says, a manufacturer buys components in equal amounts from 3 different suppliers. The probability that components from supplier A are bad is 0.1. That components from supplier B are bad is 0.15. And that components from supplier C are bad is 0.05. It asks you to find the probability that a component selected at random will be bad. And if a component is found to be bad, what is the probability that it came from supplier B?
This is part A, probability of bad component. That's what we want to know.
Yeah.
Now, intuitively, you realize we've got 3 different bins, and each one, now he does not state this explicitly, we're assuming the likelihood to grab a part from all these bins is the same. So he's saying the probability of grabbing a part from A, I'd say, whatever, I want selection, so probability of selection equals 1/3. In other words, it's equally likely that you grab a component from bin A, B, or C. With me on this, class? After that, just intuitively, how do you figure it out? Since they're all equally likely, you would take what? If you want the probability of a bad component, well, you take 1/3 times selection from A, 1/3 times that, plus 1/3 times that, plus 1/3 times that. Y'all with me? Now, I think I put the solution up here. And so, in that solution, it says, if it's bad, we call it D. there's 3 bins, here's another bin. This means a bad component. So the way your intuition works is correct. The probability of getting a bad component, or probability of D, is going to be probability of selecting bin A, I guess. I'll just call it 1/3, they're all 1/3, times the probability of it being, it being bad from A plus 1/3 times the probability of it being bad from B plus 1/3 times the probability of being bad from C, which is just 1/3. The only thing you do is add them up. 0.1 plus 0.15 plus 0.05. And that is going to be, let's see, I got 0.25. So I got 0.3 over 3, and it should be 0.1. And I think that's the right answer. You all with me on this, class? Now the next part's a little trickier, but this is the one we're based. You gotta have a clear idea of this. Remember the way this problem was set up here. We had to identify something. These are events. Probability from A, B, and C are different. Now probability of D is something that obviously overlaps these. You all with me? Because you can have failures or non-failures in all these bins. So then he says the probability, they want to know the probability of it coming from bin B, I think, isn't it? They want the probability of coming from bin B given it's bad. This is the way the solution is stated. There's different ways to write this, but in fact, what you're saying is we know it's bad. Now what is the probability it came from B? Do you remember Bayes' theorem? All right, what did Bayes' theorem say here? Well, that's really the probability, right, of it coming, or being bad and coming from B, right? Everybody with me on that? And then it's what? Times the probability of B over the probability of coming from D. Now, do you remember how Bayes' theorem works? Remember I started with that intersecting space and then I broke it up, and this will come out, usually it's A and B, I'm using D instead. With me, class? So what is that gonna be? I'm asking you things you probably know the answer to. If you haven't done it, it's very important you understand the reasoning here. So first, I want that. That's what's being asked for. If it's bad, what's the probability it came from the middle bin B? So I need this. Do we have the probability of a failure from B? Class? Yeah, and what is it?
0.15.
I hope everybody can see it. So it's 0.15 here. And now the probability of B being selected, I said they were all equally likely, which means 1/3. Y'all follow me? This is a good problem. It's very clear. And a problem like this on an exam, I'd expect those that understand the concept, they can just fly through this. Those that are unsure will get very confused trying to find some way of expressing what's going on. Then it's probability of a failure, which is probability of D, correct? 0.1. Now, what does that come down to? Well, that's 15 over 10, or 3/2 times 1/3, and it looks like it's 1/2. Is that the right answer? Now, the reasoning is easy, right? Here's where it gets skewed a little. And this seems like a problem that Chan would, if he'd find a way to make this really complicated. Suppose the probability of selecting from bin A is 1/5. And then the probability of this bin is going to be 3/5, and this bin right here is going to be 1/5. Follow me? Now you've got a skew in that. So the first answer changes. Y'all with me on that? It would just, the only thing you do is substitute the different probabilities of selecting from those bins times the failure rate. And then, since that happens, the probability of D, of the failure changes. With me? Probability of a failure would change. If that changes, here's where it gets interesting. That changes, changes, and that changes. Everything changed. Follow me? It all, and you gotta be clear about that. We could add another bin, D, or not D, E, follow me? In bin E, we could have components, and we could say the probability of a failure is like 0.001, something like this. And then the probability of selecting from that bin would be something where we distribute the selection. Then it would get more and more complicated, but it always, the essence of it is failure and the selection from the bin. Y'all with me? Make sure you know how to think about those problems and do them. And this is where people get really, I don't know, if they don't really understand it, on exams especially, they don't even know where to begin. So you gotta make sure you understand it. With me? And there's almost, like, you can't give partial credit. The kid, they don't even know where to begin. They just write a bunch of stuff and everything's wrong. And that's the bad thing about this class. It can basically boil down to, I got nothing on this problem. I didn't know where to begin, and you can fail. And in the summer, I don't want to scare you. I'm trying to encourage you. I don't know statistically about this. I've never done this, but I see more people failing my courses in the summer, percentage-wise, than the regular year. And the only reason I think of is probably it's condensed. Instead of 15 weeks, it's 10 weeks. And people are just generally more relaxed in the summer. Don't get in that habit of just clearing stuff off, because the grades, Mark Nelson hasn't told me this to my face, but the grades given in the summer don't need an average amount of A's, B's, and C's. You can fail the whole class here, and it doesn't matter. So just be encouraged. I'm not trying to scare you. I'm just trying to give you the reality of the situation. Right? Okay, enough of that. All right. Next, I wanted to do these sequentially kind of quickly, but I wanted to make sure everybody understands this. Because I know, when I looked at this last night, I thought to myself, if I gave a quiz tomorrow, unannounced, I wonder how many people could do this without a problem. And I started puzzling about this. I wasn't sure. 2.23, this is a distribution one. Now this, first of all, I gotta make sure you understand this. Here, they have now, this is going to be the cumulative density function or cumulative distribution function, right? And f of x here really is the integral from minus infinity to x of f of x, and you can call it x prime dx. What it means is it's the probability of x being f of x is defined as the probability of the random variable x being less than or equal to small x, which is a singular value, like 3, 5, and 7. You with me, class? So that's what it means. If you look at a density function, so if this is x, and this is f of x, and you look, I'm going to start at 0, but if it does something like this, we know the area under that curve is 1, right? So really when we talk about, if this is the value of my x right here, the area under this, right there, would be capital F of x, or the cumulative distribution function, right? I'm going to ask the class some questions. And just think about this and respond. But don't respond out loud, just think about it. If I'm going to put the actual value here. So here's f of x in this problem statement. He says it's some value a, and he says it's 1 minus exp. This is an easy problem. And here it's going to be 1 minus, oh, wait a second. I think it's minus.
It goes minus x minus 1.
And not absolute value either, right? X minus 1, correct?
Yes.
All right, and he has this. And this is for x greater than 1, less than infinity, I believe. That's the range. And f of x is 0 for x less than 1. And what it's really saying is, anything less than 1 has no chance of occurring. But that is the cumulative distribution function, right? So there's some things, first it has to be non-negative. I think everybody knows that. Second, what happens in the limit is you go over the total range possible. It has to go to 1. Everybody with me on this? So now, if you take a look at this, f of x as x goes to infinity, this, what happens as x goes to infinity here? If I have infinity minus 1, it's still infinity, right? E to the minus infinity is 0. So it's really just a, right? A has to be less than or equal to 1. That's the first stipulation, right? What is the other stipulation of this one? Just think about what f of x is. It is an integration of the density function, right? From minus infinity to any point. Well, if you take a look at this, this isn't drawn for that case, but you don't need to write this down, but just think about this for a second. If you look at this, if now I put down capital F of x here, and this is x, we know at 1, it is 0, right? After that, from there on, it's going to be increasing, right? Matter of fact, capital F of x has to be monotonically increasing, which means it has to be going up, right? But right here, what is the value? 0, right? Just where you're beginning to get into the probability of an event occurring, it's 0. There are no impulse functions here. That has no impulse function, so you don't have to worry about a singularity. So that means f of x equal 1 is 0, right? First, you all agree with that. Now, you can see this is almost, by definition, going to happen, right? Look at this. If I have 1 minus exp of 1 minus 1 is 0, right? What is e to the 0? 1. So I have 1 minus 1. By definition, it happens. Agreed? So what I can say is, when I look at this right here, I know I had this, and actually this, this has to equal 1 right here, not just less than. Do you agree with that, class? And the reason is as this goes to infinity, as x goes to infinity, this has to approach 1, correct? Just look at this. A times 1 has to be 1. A is 1. Do you agree with that? Everybody follow me? All right, we've got A equals 1. What's the next part?
What is f sub x of 2?
Okay, now look. We've evaluated A as 1, right? Let's just erase it. What is this at 2? That's all he's asking. It's that simple. Well, it's 1 minus exp to the minus 1. Do you agree with that? I think that's 0.632. I did these last time. Is that right? It's just 1 minus e to the minus 1. I think it's 0.632. Isn't that?
I don't think there's a solution for that one on here, but.
Well, trust me, that's what it's going to be. Y'all follow me on this? How many do? All right, what's the next part?
What is the probability that the random variable
This is important.
lies in the interval 2 is less than x and x is less than infinity?
Less than infinity?
Yes.
Now, how do you do that one? It's not hard. Let me ask you this. If you think about this, we're talking about the range of, I'll try to sketch this right here, f of x. I want to make sure you see this. distribution function, it starts at x equals 1, right? If you look at that, it's 0, and it's going to grow asymptotically, and it's going to be basically this. Right? And it's going to go to 1. Now they say the probability is between what 2 points? 2 and infinity.
Yeah.
So it's really saying, what is the probability it's between here, which is 2, and infinity, right? Well, what is the probability, or what is this value, f of x of infinity equal? 1. If I take 1 minus the probability it's less than 2, isn't that the probability it's greater than 2? How many see this? You follow me on this? So what I can do is say this is really going to be 1, because that's the probability is less than infinity. That it has to be. Remember, this is cumulative, so this value of x has to be less than or equal to the value. At infinity, it's got to be less than infinity. So it's 1. I have 1 minus the probability of f of x of 2. And that should do it. Do you agree with that, class? How many do? You see, it's not meant to be hard. That's the reason I chose these problems. Because if you understand, this is obvious, I believe. It's much easier than some of Chan's problems. I looked at some of these, and his problems get pretty complicated just before you get to the concepts applied. So this is really what? 1 minus, think about this is 1 minus e to the minus 1, right? And that's just e to the minus 1. I think that's like 0.3 something, 0.3, whatever. Do you agree, class? What's the next part?
What is the probability that the random variable lies in the interval 1?
Between 1 and?
1 and 3.
All right, so let me do this one. So now they want the probability that the random variable is greater than 1, but less than 3.
It can equal 3 too.
What?
I don't know if it's significant, but it can also equal 3.
No, not in these problems. This is a continuous random variable. Discrete's different because you could have, I mean, if you had delta functions or impulse functions, anything with a discontinuity, then you have to be careful of that. But right here, you don't. You know, with me, it's a continuously changing finite value, cumulative probability or cumulative distribution, and we'll find out in a second that the probability density function is also. So how do you do that problem? Let me ask you this. This is meant for you to see the obvious. Where does the non-zero probability begin of the cumulative? At 1, right? So really what we're saying is, here, if you think about it, it starts at 1, right? From 1 to 3 is all possible values less than 3, correct, class? So if I want the probability of all values of x less than 3, that's really the statement if you think about it. Isn't that 1 minus the probability of all values greater than 3? Y'all with me on this? So what is that going to be? Or you can, for this one, what would it be? Actually, we can do this real easy. Isn't this simply f of x of 3? Isn't that the probability of x being less than 3 by definition? And the probability it's less than 1 is 0, correct, class? How many understand that? It's meant to be very easy, and you should see this very clearly. If you don't, please be attentive to these type of problems and to get to the point of understanding. So what is that going to be? Well, it's 1 minus exp, and here it's going to be minus x, which is 3 minus 1, or it's 1 minus exp to the minus 2, and I think that's 0.8 something. I mean, you all with me? Is it 0.8 or what's the actual value?
It's 0.864.
Okay, now finally, is that the end of that problem? I want to ask one myself, and you tell me how to do this. What's the probability that x is greater than or equal to 3, less than or equal to 5? How do you do that?
So did you fx of 5 minus fx of
fx of 5 necessarily will be greater than fx of 3, equal to or greater, right? Because it's monotonically increasing. So I take fx of 5 minus fx of 3, and I'm making sure that you see this. So fx of 5 minus fx of 3. By the way, you can never have a negative probability of something occurring, so if you switch them around, you get a negative value, with me? So what's that going to be? It's really what? E to the minus 3 minus e to the minus 5. If you just do the math there, correct? The ones are going to cancel. The f of x has a 1 minus, that's the, or I should say, I better do this carefully. That actually is not true. It should be e to the minus 2 minus e to the minus 4, and here's why. When I put in and get fx of 5, I have 1 minus exp to the minus 4. Do you see that? Then I'm going to take that and subtract from it 1 minus exp of minus, and it would be 3 minus 1 is minus 2. And because of that subtraction, you flip them. And what do you get from, I don't know exactly what you get. You can take e to the minus 2 out in front, you have 1 minus e to the minus 2, so what is that?
0.117.
0. What was it?
117.
17?
Yep.
Okay. I'll ask questions like this. All right. The next problem, I'm trying to go through them quickly. I think if you have any problem understanding, please ask a question now. What was the next problem I gave? They're all meant to be built on prior, not all, prior, I think. Maybe not.
Yeah, it does. It's asking to find the probability density function of the random variable from the previous problem.
All right, so f of x was equal to 1 minus exp to the minus x minus 1 for x greater than 1, less than infinity, greater than or equal to if you want, but it doesn't matter to me. Now, what is that going to be? What is f of x by definition? It's the derivative with respect to x, the variable, of the cumulative distribution function, right? Everybody with me? I want to just show you one thing I would do. I would come up here and I'd say this f of x of x, f of x of x. I can restate that as 1. This is just how I do it. You don't have to do it this way. It would be e to the 1 times e to the minus x. Can everybody see that? And that would be for x greater than 1. Now, just do it. What is this going to be? Do y'all follow me what I'm doing? I simply said, well, if you multiply through, and just, go ahead and say it. I have e to the minus x times e to the minus 1 or e to the plus 1. I put the plus 1 out in front right here. And the reason I do it's a constant. You agree, class? Now, what's this going to be if I take a derivative of it? Well, the derivative of minus e to the 1, e to the minus x would be what? Minus or plus e to the 1, e to the minus x. So this is just going to be e to the 1, e to the minus x for x greater than 1 or equal to 1, less than or equal to infinity. Do you agree with that? And it's 0 else. Do you agree? First, how many do? With me? It's a density function. Now, what else it asks?
It asks for using the probability density function, find the probability that the random variable is in the range from 2 to 3.
Now, we could get it with the cumulative distribution function because we did that, or did we? Maybe we didn't, but we could get it very easily. Do you agree, class? So how would you do it with the density function? Now I'm going to say this is the density function. This is my f of x, and it's 0 else. So I'll put it right here. So now if I want, using that density function, if I want the probability of x being greater than, is it 2?
Yes, 2 to 3.
How do you do it, class?
The integral.
You gotta have an integral. Integral from the lower limit 2 to the upper limit 3, right? That's the range of the density function, e to the 1, e to the minus x dx. Do you agree with me?
What about the, wait, 1 plus, isn't it 1 plus that?
You see how I have e to the 1, right? This is this, right? Take a derivative of that. It's just gonna be e to the 1's a constant. The minus there, when I take a derivative of this, brings out the minus, right? Times e to the minus x, right? So in fact, this is f of x. See that? Do you agree? Now to do the integration, what do you get? Well, I can take e to the 1 out in front. Do you agree with that? Now I integrate e to the minus x. I get minus e to the minus x, right? And I evaluate from 2 to 3. I want to show you a trick here. Everybody with me on that? This is what I do. I put the minus sign right out in front. I'll slow down, by the way. I know I got some note takers here, so I'm moving a little quick because this was, I stated I thought the solutions to all of them. I think that I did put the solutions manual up there, so if you want, you can look back and see the
A lot of
solutions.
the solutions weren't in there, or that I couldn't.
What's that?
They were hard to read, some of them, and they were,
That's an understanding.
some of them were missing.
Well, there was only one missing, and that's the one I
I
did on
couldn't
the
find
board.
it.
That was the only one missing. I can't help it, but I did the solution for that. Anyway, getting back to this one right here. Here's the trick. See that negative sign right there? Because of the integration. I can get rid of it if I switch the limits. So put 3 down here and 2 here. Can you follow me on that, class? That's what I always do if there's a negative sign after an integration in front of the remain, what I have to evaluate. I just switch the limits, get rid of it. And then that means it's simply e to the 1, and it's going to be e to the minus 2 minus e to the minus 3. Now you can go ahead and multiply e to the 1 through here, and you can get simply e to the minus 1 minus e to the minus 2, correct, class? So you can say that's e to the minus 1 times, and it would be 1 minus e to the minus 2. Or wait, let me do this, sorry. It would be e to the minus 1 minus e to the minus 2. We did this one a second ago, didn't we? Oh, let me take it back. We did. Can somebody give me that? Do you have that one?
Yeah, 0.232.
I don't know. I think that's the right answer. What else does that answer?
Using the probability density function, find the probability that the random variable is less than 2.
What does it amount to? Now that one, we got the probability it's greater than 2, right? Here, I mean, this is using the probability density function to 1 minus that, right? It would be the probability it's less than 2. But we're going to do the actual using the density function. So here, now they want the probability of x being less than 2 or equal to 2. Remember, it starts at 1. That's the only that's where the density function has a non-zero value. Agreed, class? So what's going to happen? You're going to get this. It's the integral from 1 to 2, if you want to do it this way, of f of x dx, right? And that's going to be equal to the integral of e to the 1, e to the minus x dx from 1 to 2. I take e to the 1 out in front, and I get minus e to the minus x evaluated from 1 to 2. And I simply switch limits, and I get e to the 1, and then I get e to the minus 1 minus e 0. Let me just do that. I want to make sure I set this one, so it's going to be, switch the limits. I have e to the 1 times e to the minus 1, or 1, minus e to the 1, e to the minus 2, or e to the minus 1.362, I think he checked that. Is that right? E to the minus 1? 1 minus, oh no, no, it ain't. It's gonna be 0.6 something, sorry. This is gonna be 0.6, what is it?
32.
2632.
Okay. Is there another part?
Yes, so that's from the mean.
How do you get the mean? Your calculators will come in handy, but how would you get the mean? Then I'm gonna show you another trick. Well, actually, no, I'm gonna just show you. So now he wants the mean value of x, which is the expected value of x. So how do I
Would
get
you
it?
multiply that by x?
Yeah, actually, you're right. What I'm gonna do is simply take the integral from 1 to infinity of x times f of x dx. I guess I could show you this one trick. So that's equal to an integral from 1 to infinity of x. And then it's gonna be times e to the 1, e to the minus x dx. Do you agree with this? And I'm gonna break this out. So this is the integration. This is an integration by parts. Do you agree? I'm gonna ask you something. How many have calculators that are capable of doing this? Symbolic integration, or actually this isn't symbolic, it's defined values, right? Can your calculators do this or not? Class? Did you use a calculator to do this? We can do it. I'm just curious how you did it. Sometimes, I don't know if Bashir does this, but other professors, I think Matthew Kirshner, he doesn't allow calculators. Is that, anybody have him? Now, if I did that, I would make sure that I told you you would have to be able to integrate by parts for these things. But in this day and age, integration by parts is, well, you can do it into math. You don't have to at this point. And if you did want to do integration by parts, you would say what? E to the minus x dx was du, right? Then you'd say u was x. And then you would do you remember how to do these things, right? We could do it that way. But I'm going to show you while you're doing, try to do this on your calculators, if you have one. And remember, there's an e to the 1 out in front, but I'm going to show you something else. And I forgot which page this is on. The proof on this one taught me. This is Chan's book now. And I'll tell you one thing about this. This is clever, this one, but it saves you, maybe saves you at least some time. And I'll give you the number in a second. This is chapter 4. This is on page 199 of Chan's book. And he's going to say, this is a cool proof on this one, but it's a little tricky. Remember what I have here, that's integration by parts. Now if you want the mean of x, or the expected value of x, technically, it's the integral of x, f of x dx. dx. And really it's from minus infinity to plus infinity. But you'll find out that this is really equal to the integration, and it would be, assuming that x is greater than or equal to 0, it would be equal to the quantity 1 minus f of x of t dt, and it would go from 0 to infinity. Now, it doesn't seem like that's possible. I don't even know if I should prove the whole thing, but this is, again, the way he does it. He's making a statement, x, the random variable x has to be greater than or equal to 0, or it will, the integration gets more and more troublesome. So I looked at this, I've never seen this before, this right here. So f of x, he replaces the variable x with the variable t, right? So how can this be? Had anybody looked at this in the book? First, I want to tell you it works. It's tricky. So what he says is, this value 1 minus f of x, okay, remember, f of x here, of anything, but of t itself, it is really equal to the probability that t, or I should say that the random variable x is less than whatever the selected value of t is. And that's 1 minus the probability that the random variable x right here is going to be greater than t. You all follow me on this class? I'm just doing the reason. If you know that this cumulative is less than or equal to t, then 1 minus that is greater than or equal to t. Do you all agree with that? So now I come over to here and I say that this is actually equal to the integral from 0 to infinity, here's where it gets crazy, of the probability of x, of, here it's going to be t greater than, or I should say x here is going to be greater than t. Y'all with me? It would be dt. Still doesn't look like I'm going anywhere with this. With me? Now what is that? Let me do it over here. I just want to finish this thought and get to a couple other things. I want to try, lucky, get the Gauss. So now I come over here, and that means for my expected value of x here, it's equal to, remember, all this was under this, or inside this integration, but now I change this to make that function greater than t. I have an integral from 0 to infinity, and now, since I replace, I'm going to replace this right here with the probability that the random variable x is less than or equal to t. So think about this. We have the probability density function. Just listen and you'll see why I'm saying this. It's confusing. So because I have the probability density function, now I can put an integral in here, and it would be from t to infinity. That would be the range of where I'm going to say I want that probability. Follow me? Probability of x, random variable greater than t. T is the lower limit of f of x dx as such. And this right here is what that is. And here's the crazy thing. And now, if I look at this, I still am not seeing how, and then there's a dt here. There's dt on this. I still don't see how I'm going to get the mean value out of that. With me? And here's what he does. It's a trick. And on the next page, if you look there, it's page 200. Better write this down. He shows you graphically what's going on. And maybe I put it over here. So follow me on this. If you here have x, and this is t, and if I look at this, I'm just going to put a line like this. Makes sense. So if you take a look at f of x x dx, it's really gonna be an integration over a slit here. Now, this is hard to see, but you had calculus, you understand this. This would be an integral of f of x of dx, and it would be from t, right here, to infinity. Remember, x is this way. It's a little hard to see. Can you all follow me on this, class? When you did calculus, you did 2D integrations, right? You could always change if you integrated x first or y first or whatever, t first, as long as you didn't violate any of the bounds. So if I do this, what I can do is say that this expected value of x, I don't expect you to get this 100% right off the bat. Now we're going to do something where I'm going to go ahead and have that integral from 0 to infinity here. But now I'm going to put the integral, and I'm going to get from x goes from 0 to t. So this would be x equals 0. This would be some value t. Remember, the lower limit is t out there. And I'm going to say it's the integral from 0 to x. And I change the order. I put dt first. And then, after that, now I put f of x. And then I put dx, but now dx is going to go from 0 to infinity. Can you all follow me on this? Okay. When I do the dt integration, it's in his book. I spent a little time looking at this. I thought that's a clever trick that he did. When I integrate dt, right, first, I just get t from 0 to x will be equal to x, right, times f of x dx, and this is going from 0 to infinity, and that is the mean value. So, in other words, saying all that, what I'm going to say is, what I can do, ultimately, it's in the book. I'll tell you the real reason I'm telling you all this is to make your life easier, not make your thinking painful. If I want the expected value of x, you don't like integration by parts. I think we all agree with that, right? Look at this. The cumulative distribution function for the problem we're talking about. If you just integrate that, it's not hard, is it? All right, matter of fact, let me set it up for you. So if that's the case, and this is the reason I said this, because if you want to, this one will make the mean value for a lot of cases easier, much easier, because you got the cumulative distribution function. So for that problem, if you remember, f of x of x, this is the mean. We got the probability density function for that, for the problem, right? It's just e to the 1 times e to the minus 1, correct, class? But that's the cumulative distribution function, right? Now listen, see that right there? So now I can say, if I want the expected value of x, rather than doing x times f of x, which you can do, it's a simple, it's integration by parts. I know I asked you for the answer, and I'll get back to you, but y'all with me? What I can do is this, I can say, well, it's the integral, technically it's from 0 to infinity. I'll get to how we do a range change in a second. And it is 1 minus f of x, and with t replacing x, so it's going to be 1 minus, and here, it's going to be e to the 1 times e, and this is going to be minus t, as such, dt, but there has to be a stipulation that t is greater than or equal to 1, because remember in that distribution function, the statement over there says that x has to be, or the argument has to be greater than or equal to 1 for it to be valid. It's 0 below that. You all with me, class? Are you with me?
Following.
I'm trying to be clear, but I know this particular method is a little irritating. The real benefit is it's easier. At the end of the day, if you believe that this right here will get you the mean, just like this will. This is harder because it's integration by parts. Let me be really clear where it gets harder. Is all of a sudden if f of x is something more complicated, instead of just 1 minus e to the minus, suppose it's 1 minus or 1 minus e to the minus x squared over some constant. With me? That's a lot more complicated to do an integration of. For this one, if you look at this, what does it come down to? Let's see if we get the same answer. I have this is the integral from, really it's going to be from 1 now, 1 to infinity of the quantity. I have 1 minus 1, which is 0, right? And then I have plus, and it's going to be e to the 1, e to the minus t dt. Now follow me on this. Y'all with me? I just broke it down. This, the last part is going to be positive, and that's going to be simply e to the 1. And then when I integrate e to the minus t, I get minus e to the minus t. And if I just change the order of integration, I get e to the minus 1 minus 0, or it's 1. Do you all follow me? I didn't do this last night this way. What's the answer for the mean?
I got 0. For
the
that
mean?
one?
No, for this, this is not going to be 0.
I did it for that one.
For this,
Mhm.
can't be 0. 0 is not even a possibility because you must have integrated. When you do this one, the integration is from 1 to infinity. The only values start at 1, right? You can't have a mean of 0. You're with me on this class? What was the mean value you got for that?
You do it on my calculator, but I got 1 doing it by parts.
Yeah, it'll be 1. In other words, I don't know what went wrong, but that's the same value here. This is easier than doing integration by parts. I don't know if you agree with me, sir.
Sorry, this might be a dumb question.
That's not.
You've got 0 to infinity, 1 minus, where are you?
Where are you talking about?
So from.
All right, because remember, this value here is only valid for what? For the argument being greater than 1, right? That's the reason I changed the lower limit to 1.
You remove the ones, the 1 minuses.
Well, if you look at the original thing here, just multiply it through. You're going to get e to the minus e to the plus 1. That's this. Minus e to the minus t. Times e to the minus t. Is that what your question is, or is it this?
Oh, okay. I'm seeing it.
In other words, these two get whacked, and you're left with that.
You're just doing basic arithmetic.
Yeah, really. And so that integration to me is a lot easier, and it's easier to get the mean value. That's my whole point on this.
So is that just a formula then that you can use for these types of episodes?
Yeah, but the reason I showed it with that problem is it's easier that way.
So you can basically do that, or for any given problem.
You can do integration by parts. Now, your calculus, now I'm not an expert at calculus, they should be able to do both symbolic and actual integration when you have hard limits. I think they can do that, right? So you can do it on your calculator, but that is right. I don't know what you did wrong.
I put it in my calculator and it gave me 0, but
Something, you must have had something off because it can't be 0. Now, you can misuse your calculators, and that happens all the time where you're not exactly, you don't know how to operate it correctly. That's the reason I prefer to do it this way, because you're going to get the right answer if you understand the ideas.
What in the solutions it has is it 2?
Yes, I got
I think
2.
it's equals 2
For what?
for the mean.
Not the mean square?
It has the mean as 2.
All right, let's try this.
Because when I did it just doing it by parts, and I was able to get 2.
Well, let me just see, because if I did something wrong, I'm really gonna feel bad. But first, let's go here to make sure I didn't do anything wrong. This will work. If I look at this, I have 1 minus 1 is 0. And this has to be from 1 here. So I'm gonna have an integral from 1 to infinity of e to the 1 times e to the minus t dt. First degree. Let's make sure I didn't do anything wrong. E to the 1. And then when I do the integration here, I get minus e to the minus t, evaluated from 1 to infinity. Agreed? I get 2, I'm not sure. And that's going to be switch limits so when it's 1, it's e to the 1 as times e to the minus 1 minus 0. That looks like 1. And if you do, I'm not saying you're wrong, I'm just trying to figure out where it could have gone wrong. And now if I come over here and I look at the integral from 1 to infinity, because that has to be the limit, remember? And then it's going to be of x times quantity e to the 1, e to the minus x, that's the density function, right? And this is the range it begins, dx. Well, that itself is going to have e to the 1 out in front times the integral of x e to the minus x from 1 to infinity dx, right? So now we talk about this integration of just x e to the minus x. And here, I'm going to let u, or I'm going to say, v equal to x and du here equal to e to the minus x dx, correct? And that's a lousy u, but so now d of u is dx, and that means x is equal to minus e to the minus x. Do you agree? I mean, I shouldn't say x. That actually, if this is u, this would be dv, or v. I'm sorry about that. You with me? So then I come over here, and I know I'll just do the integral by itself of x. We'll put the limits on in a second. That's going to be u times v. So it's x, or it's minus e, minus, and this is going to be u or x, and it's times that e to minus x. I'm just putting in the minus only. And then it's going to be minus, and here you're going to have that integration of v, so it's a double minus, e to the minus x right there. It's going to be times e to the minus x. Unless I did something wrong here, I may have. It's uv. Sorry. And this would go from 1, or actually I have to integrate that. Let's see what this becomes. So this is minus x e to the minus x. And that's going to be minus e to the minus x. Must have been a minus there somewhere. And that's going to go from 1 to infinity. I'll go ahead and just change that. And so that's going to be I must have done something wrong in that. Right now I'm trying to hurry, but Did you do this, anybody did it in calculator X? I'm sure I did something wrong, I'm trying to.
They're both right. That integral equals 1, and that one is 2. Like both are right at the same time. I think something's wrong with the setup on that one maybe, because I did both of them on my calculator.
X e to the minus x integrate from 0 to 1. You say it's 2?
Will be like original one with the little f over there. That integration by parts is 2.
Give me 1 second. This doesn't sound right. Something, I'm missing something, unfortunately. I'm not seeing it right now, but let me just look at one thing, because I did this last night. So this is, what problem is that? 3.2, or 2-3.2, or?
2-4.2.
Wait a second, 2-4.2? That's the one with the sign variable, isn't it?
2-2.3, I think.
Yeah, 2-2.3 makes, that sounds right. And I don't have that here. Anyway, let me check on that one. But the mean, what's the solution after this one? 2-. No, that isn't the mean value on that one either. Mean value. No, this is problem 2-4.2. Wait a second. No, it ain't. I'm sorry. I'm gonna have to look at this. Both should give the same answer, and I gotta be careful. I don't have this one here, but one other thing, I mean, we got a few minutes, so anyway, I was trying to get through all this, but I wanted to talk about now when you have, the next thing I want to talk about, I'll check this one out. I'm certain there's a very subtle error here, but those do work. If anybody wants to follow me up to my office afterwards, I'll do this problem correctly. All right, so now I want to talk about something. If you have a density function for, say, a random variable x, and you have another variable y that's a function of x, what's the probability density function for y? This is important too. And I have PDFs of this, but I think, I'll give you an example in the book. Okay. So suppose I have f of x right here is a density function for x. I have a random variable x, and it has a density function, probability distribution function of x here. We know that, doesn't matter what it is. And now we have equations. Now I can say that y here is a function of x, and it's basically going to be, doesn't matter what it is. Let me give you an example. Say it's 5x plus 2. With me? Nice easy function to get a handle on. Doesn't matter what that function is. So if I say, I want to know the probability distribution function or f of y, how do I get it? And the real thing is, you've got to see the relationship between y and x. Once you have that, you'll be able to do it. So really, you start by saying the probability of x, the random variable being less than x, is really the integral from minus infinity to f of x dx. Then we take a look at this. This is the probability. Now we want the density function of y. So I look at this and I say, really, I have y minus 2 over 5 is equal to x. Makes sense? So when I say I want to know the probability density function for x, random variable, being less than x, it's really like y minus 2, actually, let me do this. Probability Well, I'm gonna run out of time on this one. Hold on. If I'm trying to do this thing, I think I'm gonna get some stuff I'm supposed to do. I'm gonna just tell you this. I'll see if I can finish this right here. So I did. I want to go, first of all, and say, I have a density function. I'm just going to show, this is versus x, and this is f of x of x. It doesn't matter what it looks like. Something like that. When I say the probability of x being less than or equal to, I call it x prime, is this area. Now, the relationship between y and x. I say y is equal to 5x plus 3. So I can take y minus 3 over 5 is equal to x. And the probability of x being less than some x prime, if I think about this, or basically I can say it this way, is the same thing as the probability of y being less than or equal to 5x plus 3. This is easier to see. The probability, and I'm going to do it this way, probability of x like that is going to be a random variable less than x is the same thing as this probability of y less than 5x, whatever x is. This should make sense to you. Do you agree with this? So if you think about this, I look at this, and that's the probability, and I have y minus 3 over 5 right there being less than that x value, correct? I'm just trying to show you the relationship. So if you had, and you plotted, if you wanted to plot f of y here, since that's the relationship, what this is going to be is really an integral from minus infinity to y minus 3 over 5, and here it's going to be f of x dx. Now the upper limit is the thing I'm stressing here. Now if you have that, and you take a derivative, what this really is now the probability of the value being less than y minus 3 over 5 take a derivative of that. Yeah, of y, of, and it's just gonna be using this argument to evaluate f of x there. And so then I put f of x with the argument y minus 3 over 5 in it. And that will be my f of y of y. I'm gonna give you some stuff to do, and I'll do examples of this on Friday. I know I'm out of time, and I didn't get to finish it. I wanted to get to Gaussian today, but I need to go through this. And there are slide sets I put in there. I'm gonna identify a certain group of slides to take a look at, and then do some problems. The quiz on Friday is gonna be dealing with mean squared, I think mean squared problem. And for now, just if you wanna find the mean value, use x times f of x. If it's a dx, a continuous function, and there would be a sum of just the x of n times the probability of x of n. You'd have to sum those if it was discrete, with me? But the problems we went over earlier in class, you have to know in the prior ones. And so mean squared, and variance, and then the problems were Bayes' theorem was some of the stuff that I showed you. Like all these problems are very good, and they're very, I think, basic, and they're not too complicated. Because if you ever look at some of the problems in Chan's book, they